Welcome to the lecture on physics, and today we will discuss units and measurements. In this topic, what we will cover today will be, we start with description of units and we will talk about fundamental and derived units, and then we will look at some different systems of units, and in particular we will look at the set of units which we follow called the SI units. And after that, in the remaining time, we will study measurement of length, mass and time, and we will also look at the range of measurements for these quantities. So, let us start now. Whenever we study physics, our study of physics is based on measurements, and the measurements are very fundamental. Any quantity which we have to study, we have to measure that quantity, and qualitatively we can think of measurements in terms of some simple questions. Let us say, what is the time interval between sunrise and sunset? How much is that duration? What is the temperature when milk is boiled? When milk starts boiling, what is the temperature of milk? Or we can say, how far is the bus stand from my home? It is at some distance away, how far is that? Or we could talk of what is the electric current in a wire. And to answer these questions, we start by learning how to measure physical quantities. So, our starting point is, we start by learning how to measure physical quantities. Now, the physical quantities which we talk of, the quantities which are to be measured, they include entities like length, mass, time, temperature, it could be force, pressure, and so these quantities we want to measure. It could be how fast an object is moving, so we will talk of speed. So, what we do is, we define a physical quantity by setting up a standard and assigning a unit to that standard. For example, we take a specific length and we say this length is 1 meter. So, that means now this will be a standard length, we call that as 1 meter. Any other thing which has to be measured, we express it as a multiple of this length. And when we say multiple, this multiple could be either bigger than this length, that means something like 2 times the length or 3 times the length, or it could even be a fraction of this length, half of this length. And so, this is how the units are then used. So, after we assign a standard, then what we do is, so let us write this. For example, we assign a specific length and we say it is 1 meter. Now, any other length is expressed as a multiple of this length. So, something which is twice as long as the standard length we will say this is 2 meters. And so, once we express a standard length, then all lengths are expressed in terms of this, and the length could be as small as radius of a hydrogen atom, which will be many orders of magnitude less than the standard meter, or it could be as large as distance from moon to earth or distance from sun to earth, which would be many thousands of meters. So, but then what we have done is the standard length which we have defined, the standard length which we have defined as a meter, standard length, this is what we call as a unit length. So, this is how we define standards. Now, let us say we have a particular physical quantity q, and when we are talking of length, that means this is some length which we have defined. So, we talk of a physical quantity q. So, this we can write it as n times u, where n is the magnitude of the quantity and u is the unit. Now, what you may realize, and rightly so, is the same quantity can be expressed in different set of units. For example, somebody may use meter to measure length, another person may use another standard, say a foot, to measure length. So, and that is allowed. So, what one can do is, so the same quantity can be expressed in different sets of units. So, let us say the quantity q, we write it as in unit 1, which I call as u1, the quantity q is measured and it turns out to be n1 in magnitude. So, we write it as n1 u1. Now, same q in unit u2, let us say measures n2 units of u2. Since q is the same, this obviously leads us to n1 u1 is equal to n2 u2, and This is how sometimes we convert the units from one unit to the other. The conversions are worked out using this formula. Now, a large number of quantities which exist in nature, but we require only a few independent quantities to measure them, and the others can be written in terms of the independent quantities. So, we have a large number of physical quantities, and let us say example, we have the length of something, we have area, we have volume, we have speed, acceleration, mass, force, time. So, number of physical quantities which we want to express are quite large, but it turns out we require only a few quantities which are independent and the other quantities can be expressed in terms of these independent quantities. So, this gives us the concept. The quantities which we choose as the independent quantities, we call them as the fundamental units. So, the independent quantities these are referred to as fundamental units, and the other quantities we call them as the derived units. And the derived unit, the derived quantities are obtained by multiplication or division of powers of fundamental quantities. What I mean by this is, for example, when I look at area, area will be square of length. So, area need not be taken as a separate quantity, area would be a derived quantity based on the fundamental quantity of length. Similarly, when I look at speed, speed is length per unit time, distance covered per unit time. So, it will be basically a derived quantity if length and time are my fundamental quantities. So, we choose some fundamental quantities, and on the basis other quantities which can be expressed as terms of fundamental quantities are called the derived quantities. Now, a complete set of units which we have, which consist of a complete set of units which will contain both basic and derived quantities This is what we refer to as a system of units. So, what we have in a system of units will be, it will start with some basic quantities or the fundamental quantities, and then there will be other quantities which will be essentially products or division of different powers of these quantities. So, that is how this works. Now, let us look at different units of measurement. Now, in different times and different regions, that means earlier times or in different parts of the world, different units have been used. As we have seen, any quantity can be measured in terms of different units. Now, till 1970s, basically there were three systems which were prevalent. The first system, so till 1970s, we had three major systems. The first one is what we refer to as the CGS system of units. In this CGS system of units, centimeter was used for length, gram was used for mass, and seconds was used for time. So, the units were measured in terms of centimeter, grams and seconds. Then there was another set of units which was very popular, and this is referred to as the FPS system of units, and in FPS system foot was used for length, pound was used for mass, and once again S, the time unit was the same, seconds was used for time. The FPS system is also sometimes referred to as the British system of units. And the third system of units which was prevalent was referred to as the MKS system, and here in the MKS system meter is used for length, kilogram is used for mass, and once again second is used for time. Now, since 1970s, the system of units which has been standardized in most parts of the world. I am using most parts because still we have some of the countries which use other units, but the standardized system of units is what we refer to as the SI units or system international units. Now, this in scientific, technical, commercial work in the world, we normally use SI units, and one of the basic advantages of SI units is that these units, SI units, are based on decimal system. So, because they are based on decimal system, the conversions work like in factors of 10. So, therefore, it is easier to use SI units. Now, in SI units there are seven base units which are used. In addition to length, mass and time, there are other base units, and let us list them one by one. So, the 7 units which are used in SI system, first let us look at the quantity for length. The SI system uses meter and generally is denoted by m. For mass, the basic unit used in the SI system is kilogram. So, and the symbol for that is kg. For time, the basic units used is second, and we use the sign S for this. Then we have the fourth quantity which we for which we provide the basic set of units is electric current, and the standard unit for this is in SI system is ampere, and we use the symbol A for this. Now, here of course, in SI system we use ampere as a basic unit. Now, somebody else could have used charge as the basic unit instead of current, and then they have a quantity called coulomb which could have been used, but when we define one set of units, the fundamental set for that system is fixed, and in SI system the electric current we use ampere as one of the basic set of units. Okay. So, now the fifth unit for which the quantity which we measure units is temperature, and temperature is measured in a unit called Kelvin, and the symbol for this is K. Then the amount of substance which is contained in terms of number of molecules is in SI units given by mole, and the symbol used for that is MOL. And the seventh set of basic quantity which we have for which we write our in SI system is luminous intensity, that is how bright some thing is shining, and the unit for that used in SI units is candela with symbol CD. So, these are the 7 basic set of units. Now, one of the things which one has to do is for each of these, once we define a standard unit, then its definition has to be something which has to be very precise. And so, for example, when we look at meter, this initially was the length of a standard bar which was put under particular conditions of temperature in a lab in Paris. So, that the length of that is what was defined as 1 meter, but now meter is defined in terms of length of path travelled by light in a particular time interval. How much light will travel in a given fraction of a second. So, that length is given by meter, and so the standard length of each of these, if you look at standard textbooks, you will find how these are defined, and they contain some numbers which you can see is so many times frequency of vibration, and all these numbers you can, when you look at any standard book, you will be able to get the definitions how these standard lengths have been defined. Now, so for example, we look at a kilogram. Kilogram is the mass of a standard prototype which is kept in International Bureau of Weights in Paris, and now each country has its own standard labs. In India, we have the National Physical Laboratory in Delhi, which has a particular block kept under particular condition, and so we say the mass of that is 1 kilogram, and this is equivalent to the mass of 1 kilogram which is kept in Paris. So, these two have the same mass, and that is how the standards work. Now, the time period second which we have, now this is basically the duration of given periods of radiation corresponding to some particular atom, how things move in there. So, they are very precise, all these standard units. Now, there are two more units which we define, which do not have any dimensions. So, there are two dimensionless units which are defined, and these are units for some angles. So, the first one we define is when we have a planar case, that means everything is on a single plane, and here we, and when we want to measure the angle, we define a unit called a radian. And how we define a radian is that we take a circular arc. So, we have the center of a circle and we look at a circular arc. Let the distance or the length of this arc be s, and if the angle which is subtended by the two radial lengths is theta. So, we look at a sector of a circle, the two ends of these have a length equal to the radius of the circle, and the angle in between these two is given as theta. So, then the angle theta is equal to s over r, and this is what we say is the angle theta in radians. So, the ratio of the arc length to the radius gives us the measure of the angle in a particular quantity, in particular units which we call as the radians. Now, radians is not the same as degrees, which you know, because what happens is, if we look at a total circle, now we know in terms of degrees, if I move and I come back to the same point, the total number of degrees is 360, and degrees we use a superscript with a O sign to show degrees. So, this is the total number of degrees. In terms of degrees, the angle is 360 degrees, but in terms of radians, if we look at it, the total arc length moved when I go from a circle is 2 pi r, and if I divide that by r, that means in terms of radians I have got 2 pi radians. So, therefore, what we have is, if we look at this, then 2 pi radians is equal to 360 degrees. So, therefore, we have, if we want to look at degree, 1 degree is equal to 2 pi divided by 360 radians, or is equal to pi divided by 180 radians. Then we will, all of these, the endpoints of this area will be, so this is the center of the sphere, all of these will have the radius of the sphere. Now, here the angle which is subtended with the center and the ends of this area is what we call as a solid angle. And if let us say this area is dA and the solid angle which we have, if we call that as d omega, then if I look at dA divided by r square, this will give me the value of, or a measure of, the solid angle d omega, and this measurement we say is in a unit called steradian. Therefore, a solid angle is defined as the area which is there on a spherical surface divided by the square of the radius of the sphere. So, the angle which is subtended is referred to as a solid angle, and the units of these are called steradians. Now, sometimes the quantities could be measured in units which are not the same as the basic units, but they could be multiples of these. For example, when we talk of time, then 1 second is the SI unit which we have talked of, but sometimes we could measure time in terms of minute, where 1 minute is equal to 60 seconds, or we could talk in terms of hours. So, 1 hour is equal to 60 minutes, and this is equal to 3600 seconds. So, depending on how big our duration is, we could use things like this. So, for angle we have different units. Radian is the what we call in the SI units, but also measured in degrees. And in terms of angles, one can say, as we said, when we go around a circle, then this angle is 360 degrees, but sometimes the angles may be very small, then even the degrees are further broken into small units, and the way degrees are broken, that goes exactly like what we do for time. So, when we break the, when we want to subdivide degrees for angle, then we have, we want to look at subdivide this. So, then we the smaller unit for degrees is minute. For length, for example, when we talk of length, for large distances, particularly the ones in astronomical ranges, we use a unit of length called light year, which is the distance travelled by light in 1 year, and for this light has to travel in vacuum. So, different multiples of the basic units could be there, and when we have derived units, then the derived units will be a combination of different basic units in the SI system. Now, one thing which we, when we have very large or small magnitudes, then we also use some prefixes, and these prefixes are used to give order of magnitude of the same quantity. So, for example, when we have a term, we use, if we have some quantity which is 1000 times a basic quantity, then the prefix used is kilo, and this we all know that 1 kilogram is 1000 grams. So, when we have a factor of 1000, then the standard prefix which we use is kilo. Then if the factor by which we multiply is even bigger, 10 to the power of 6, then the prefix which we use is mega. If we have another factor of 1000, that means we multiply it by 10 to the power of 9, then we use a prefix called giga, and if it is 10 to the power of 12, that means another 1000 times of giga, then the prefix which we use is called tera. For example, when we count of computer operations, we talk of something called teraflops. So, teraflops will be 10 to the power of 12. So, these prefixes are sort of standard, and the bigger one, when we go to 10 to the power of 15, then this is termed as peta. There may be more, but these are the more commonly used prefixes when we are magnifying things. Just as we magnify, sometimes we may be dividing the things into smaller units, and then we have other set of prefixes. So, for example, when we multiply something by 10 to the power of minus 2, which means we are dividing by a factor of 100, 10 to the power of 2, which is 100. Then the prefix which we use is centi, and we are very familiar with this in terms of lengths. We know 1 centimeter, if we have, that is 1/100th of a meter, or 100 centimeters make 1 meter. So, the commonly used prefixes, when we have a factor of 100, divide by that, then we have a prefix centi. Similarly, when we divide by a factor of 1000, then we have a prefix which is called milli, and this also we are familiar from millimeter and milligram. If we further divide, further make it smaller, a prefix of 10 to the power of minus 6, this is called micro. A prefix of 10 to the power of minus 9 is called nano. A very common term today in physics, we talk of nanophysics, which means we are talking of particles, or the length ranges in nanophysics would be of the order of 10 to the power of minus 9 meters. And another commonly used, a smaller dimension or smaller prefix, is 10 to the power of minus 12, which is pico. So, these are some standard prefixes which are used, and these you could encounter these in different problems. So, you should be familiar with them. Now, having seen this, let us move on to measurement of length. Well, as we have seen, the direct measurement of length this is done by a meter scale, and the most common example where you see direct measurement of length being done by a meter scale is when you go to buy cloth. Then the person who is selling the cloth takes a meter, put the cloth against the meter scale, and then if you want 2 meters of cloth, then it will be put twice around the meter, and that is how you get this. So, now meter scale, typically this would be used for a range of 10 to the power of minus 3 meters to something like about 100 meters. That is what you would use a meter scale for. The meter scale, if you realize, they are smaller graduations. It is first subdivided into 10, which makes it 10 centimeters each. Then it is divided into 100 parts, which is 1 centimeter, and the centimeter is further divided into 10 parts. So, each of those divisions corresponds to millimeter. But then if we want to measure even smaller lengths, then we have devices. We have a device called vernier caliper, which will measure up to 10 to the power of minus 4 meters, and we have micrometer, screw gauge, or also called the screw gauge, which will measure length up to 10 to the power of minus 5 meter. Now, this was the smaller length. If we have to measure large distances, clearly we cannot use a meter scale. Let us say we have to find the diameter of moon. We can't use a meter scale, or we have to measure things at a distance. Then a meter scale type of method will not be possible, and there what we use is what is referred to as a method called the parallax method. When a same point is measured by two different observation points, it looks as if the position of the point is changed. And a very simple example of this, you pick up a pencil or something and you observe the pencil by first closing your left eye, and then you observe the same object by closing your other eye, that is the right eye. It will appear as if the position of the pencil of the tip which you are seeing is displaced, and for this displacement to occur you have to see it at the background of something else which is fixed. So, even though this thing is fixed, but because we are seeing it from different eyes, from two different sets, from one eye or the other eye, the object appears to be displaced, and this displacement is what is called, the shift is called parallax. When the same point is observed by two different observation points, it seems that position of the point has changed. This shift is called parallax, and the distance, see here the distance between the two observation points, this is known to us, and this is what is exploited to find the distance from the observation point to the observed point. So, the distance between the two observation points which is known to us, this is referred to as the basis, this is called the basis. So, for typically for basis we use the symbol B, and so the distance between the set of two observation points, as we said, is called basis. So, now if we are observing a point S. So, we observe the point S from one observation point A, and we observe point S from another point B. So, we observe S from A and from B. So, A and B are our two observation points. The object S is very far. So, now when we do this, the distance from A to S and B to S. So, think of A and B as two observation points, let us say on surface of earth, and S is some planet located far away. So, the distance of A and B to S will be the same, and let us say this distance. So, distance from S to A or S to B is given by D, and this is what we want to measure. Now, the distance between A and B, which is actually the basis, is known to us, and this we say is equal to B. Then what is done is we measure the angle between the two directions along which S is viewed. So, we measure the angle between the two directions along which S is viewed. So, we measure this angle, and now if B by D is much less than 1, that means the distance is very large, then the angle, if B by D is much less than 1, then the angle theta will be small, and if that is so, then AB, that means this angle theta is small, AB can be treated as the arc of a circle. So, in that case we treat AB treated as arc of the circle, and so the distance B will be equal to d times theta, where the distance, now the angle theta is measured in radians, therefore, the distance d will be given by B divided by theta. So, we know the distance between the two observation points and we know this angle. So, the distance from observation point to the location of S can be measured. Now, there is one more quantity which we sometimes measure. Suppose we want to measure the size or diameter of a planet. So, we have a planet whose diameter is d, and we want to measure this diameter of a planet from a point on the earth. So, here what we will do is we will focus our attention on two opposite ends, diametrically opposite ends of the planet. So, we observe two points which are diametrically opposite on the planet. Now, the angle which is subtended by the two opposite points, let this angle be alpha. So, now if the distance of the planet is d, if distance of planet from earth is capital D, then we have small d, which is now the arc length. Small d will be equal to alpha times capital D, and therefore, we have either we will be able to get small d, or if we need the angle alpha, then this will be equal to d upon capital D. So, here you have to keep in mind alpha is the angle between two directions when you view diametrically opposite points on the planet. And in such measurements, when we do such measurements, then the angle which we measure, the angle will be we have degrees as we said, and we know 1 degree is equal to pi by 180 radians, and this turns out to be, if we work in terms of decimal, 1.745 into 10 to the power of minus 2 radians. And then if we subdivide the angle further, if we did the degree further, 1 degree is equal to 60 minutes. For degree we use 0, for minutes we use a single inclined line as a symbol. So, we have 1 minute or 1 minute, this is equal to 1 by 60 degrees, and this will become in radians 1.745 into 10 to the power of minus 2 divided by 60 radians. So, we should know how to convert the minutes into radians, and if the minutes have to be further divided, then we have a unit called, for the angle, called 1 second, and 1 second is equal to 1 by 60 minutes, and second we write by putting 2 of these inclined lines. So, we have 1 second, and this 1 second will be given by 1.745 into 10 to the power of minus 2 divided by 60 into 60 radian. So, we work out the divisions like this. So, if we can take an example of a problem involving such this thing, let us say we take the problem, moon is observed. Now, be careful, and in problems like this, when you solve the problems, the best way to do the problem would be to draw a figure and then work out. Now, the problem here says moon is observed from 2 diametrically opposite points on the earth. And so, we observe moon from 2 points on earth which are on opposite ends of the diameter of the earth, and what we find is, what is given to us is the angle subtended by the 2 lines of observation. This angle is given as 1 degree 54 minutes, and what is also given to us is that diameter of the earth, this is equal to 1.276 into 10 to the power of 7 meters, and what you are supposed to find is, find the distance between earth and moon. So, here what we will do is, if we just see, we draw, if this is the earth, we have observatory A here, observatory B here, and this is the location of moon. Now, what is given to us is that from 2 different observation points we observe moon, and what is given is that this angle is 1 degree 54 minutes, and we have to find the distance between earth and moon. So, capital D is the unknown here, the angle given is 1.54 meters, and the distance AB this is given to us as 1.276 into 10 to the power of 7 meters. So, therefore, to solve this problem, what you have to you know the arc length AB is equal to radius times theta. So, therefore, AB, which is equal to diameter of earth, is equal to d times the angle theta, where theta is 1 degree 54 minutes, but for you to be proper, the angle theta now you have to convert to radians. So, you have to convert 1 degree 54 minutes to radians, and then you will have the distance A be 1.276 into 10 to the power of 7 meters. This will be equal to the distance d in meters multiplied by 1 the angle theta. Now, if we look at 1 degree 54 minutes, this will be equal to 60 plus 54 minutes, this will be equal to 114 minutes. We have the conversion factor. So, this will be into 114 minutes, and we have already seen 1 minute is equal to 1.745 into 10 to the power of minus 2 divided by 60 radians. So, therefore, this will multiply by 1.7452 into 10 to the power of minus 2 divided by 60. And now, we work this out. So, we will get d is equal to 1.276 into 10 to the power of 7 into 60 divided by 114 into 1.745 into 10 to the power of minus 2 meters. So, we can work this out. We will continue ahead. We will talk in the next class of, we will start with range of length scales, and then we will look at some ways to measure smaller length scales, and we will practically demonstrate how we use two devices, vernier calipers and a screw gauge. Thank you.